Hey Tube, welcome back. Today we have the fourth solution for the problem number 14, longest common prefix. Write a function to find the longest common prefix strings amongst an array of strings. If there is no more prefix, returns an empty string. And if we got this as an example, we have flower, flow, and flight. We find that the common prefix is FL because the longest common prefix is FL because it's available all in all the strings. And today we're trying to solve this one by using um, binary search solution. So we were trying to search left and right inside the string to know where the common prefix is. So how this will work? It's basically we will just we what is let's me describe what is uh, uh, a binary search first. Let's go here and share this instead. So let's say that we have an array that has some numbers 1, 2, and 3, and 4, and 5. Okay, and we want to find an element, and let's assume that this element equals 3. And we want to know where the 3, or we want to find where the 3 is. So we have one solution is to just try to search one by one. So if this equals to 3, no. If this equals to 3, no. If this equals to 3, yes, we return it. And this number iteration, it takes what we call O of n time space, because we have it depends the time complexity, it depends how long the array is. The binary search is quite different. The binary search is that it's we divide and search. For example, we have 3. Okay, so we first divide this array into two sections. We have 1 to 3, and we have 4 and 5. Okay, so we say, okay, is 3 bigger than or equal the mid, or the element in the middle, which is 3? It's basically exactly equal to it. So we return it directly from once. But let's say that the element wasn't 3, the element is 2. What we will do this, we will say, okay, if we have mid still 3, we'll say if the 2 is bigger than or equals 3, it's not bigger. So we should ignore all of this area because 2 will not be there, and only we search here between these two characters. So it's improving the way iteration works. So let's try to continue here. So first, I want to do some base cases. So let's say if strs equals to null, or strs dot length equals to 0, we return empty array, okay, empty string. After that, I will create let min 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 length, and here I will try to it will equals infinity, and after that I will make like strs dot for each str for each string, return if the min dot length all equals math dot min, the actual min, oh no, the actual min dot length and str. Okay, let's stop here and let's discuss what we have doing here. So first we checking for an empty input. The function here, the function first checks if the input array is null or empty and returns an empty string if so. After that, we're trying to finding the minimum length. We calculate, or it calculates the minimum length of the strings in the array the common prefix cannot be longer than this minimum length. After that, we will have low and high. Let low equals 1, let high equals min len. Okay, and we create a while loop. So let's create a while loop here. I would say while low is less than or equal high. I would say let middle will equals math dot floor low plus high divided by 2. Let me just put this in another one here and here divided by 2. And we make if statement here. If is common prefix. We create this function later. Let's put this function here. And we will talk about this function's purpose. And we take 2 and I would say it is strs. If this was common prefix from strs and middle, we will do something, otherwise we do other thing. But let's just try to describe these lines of code before going into the is common prefix. So we in terms of binary search on prefix, the binary search is conducted on the length of the potential common prefix, ranging from 1 to the min length. Okay, at each step it which checks whether the current middle length serves as a common prefix for all strings using the helper function, which is common prefix. So we have from strings and middle, and we try to do it with each middle. So what we're doing here is that we say, okay, it's let's see if it's common prefix or not, but let's just try to see how the common prefix will work. So we have const, it will equals maybe like str1, and this one will equals str's 0 from dot substring 0 and len. And I'll create a for loop. I will say let I equals 1 and I should be less than strs, smaller than strs dot length, and I plus plus. And I would say, okay, if not strs of I dot starting with starts, not starting, starts with that start with the str1, we should if that wasn't the case, we return false. Otherwise we return true. And let's continue upstairs when the is common, but let's discuss the is common. So here, if the is common returns true, it means a longer prefix might exist, so it moves the lower bound up to low. I will do this in a minute, but let's just try to discuss what's going on here. So first, we taking the string 1. It will be from the first string by substring, and I want to say, okay, I want to see, okay, if I will loop through the string and compare it to the strings of 1, and I'll say it does. If it doesn't start with it, okay, that means it's not a common prefix. So what we will do is, if it's not a common prefix, what we should do, we should make high equals uh, middle minus 1. Otherwise, we make low if it was a low equals middle plus 1. So we're trying to reach for more values. Again, let's discuss this one again here. So if is common prefix return true, it means a longer prefix might exist because we wanted the longest one. So it moves the lower bound. Low equals middle plus 1. If false, it shortens the potential prefix length by decreasing the upper bound, which is high equals middle minus 1. After that, I guess we should return, but let me just return here. But what we should return? Return strings of 0, okay, dot substring, what substring 0, and math dot floor low plus high divided by 2. Okay, so after that, we're returning the longest common prefix. Once a binary search is completed, it returns a substring of this first string from 0 to the final computed index, to the final computed middle index, which represents the length of the longest common prefix found. And this is a good approach for binary search. It's a way that it could work. Let's submit and see if the code will work. If code doesn't work at all, why the code didn't work? Let's try to see again one by one. So we have if strings equals 0, we return min length, I guess so equals infinity. And for each string we have here min length, and we say that it's really met that min length and string dot length str dot length. This is the first problem. Okay, middle dot floor time. Okay, so I have a problem here. Low equals, okay, so low equals 1 and high equals min length, and we should make the let middle equals math dot floor low plus high divided by 2. Okay, and is common prefix I put the strings in middle, which is calculated here, and inside the middle here, I guess we just loop I plus plus. Okay, it's working, and I'm beating 66%. That's okay. It's not bad, to be honest. It's not that bad. So yeah, this is my solution for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problem.